mechanical power and turn them into hydraulic power. That's so you can move like your boom and your any hydraulic. It takes and turns the mechanical power of the engine into hydraulic power. Some of the main components in a piston pump are valve plate, port plate, that's part of the block, cylinder block, retaining plate, pistons, and swash plate. How a piston pump makes power is as it turns, the pistons go down and oil goes into those pistons and it'll turn and it goes back up because it's on an angle and it'll force that oil back out, and it does that multiple times, and that's where you get your power, is the oil going down and back out. There are two main type of piston pumps, a variable displacement and a fixed displacement. Variable displacement have the ability to vary the swash plate angle during operation, while fixed displacement cannot move the swash plate while it's moving on an angle. If the swash plate is perpendicular to the axis of the rotation, no fluid will flow. But if the swash plate is on a steep angle, a large volume of flow will be pumped. So the difference between a fixed displacement and a variable displacement is that a fixed displacement cannot angle while moving, while a variable displacement can angle while moving. This allows you to increase the amount of flow of oil for a variable displacement, so that way you can move your hydraulics faster or slower depending on what you want, because you can vary it. Some pumps allow the swash plate to move in both directions from the 0 point. This means that you can pump fluid in either directions without reversing the rotation of the pump. So you can have a forward and backward, but without reversing the pump. A swash plate is an inclined disc revolving on an axle and giving reciprocating motion to a part in contact with it. The part that's in contact with it is the pistons. The flow capacity is governed by the valve plate and the cylinder block. They both work together to control the flow in and the flow out. The flow capacity is also result of a couple things. The piston diameter, the piston stroke, number of pistons, drive shaft, and the drive shaft RPM. If you have an uneven and a lighter number of pistons, you generally get the lowest level of flow propulsions. For example, if you had 3 pistons, you'd have 14 flow propulsions. If you had 5 number of pistons, you'd have 5 flow propulsions. If you had 9 pistons, you'd have 1.5 flow propulsions. So this means that the more pistons, the less, I don't know what you'd say, vibrations, you get less propulsions. And a variable displacement pump means the amount of fluid pumped per revolution of the input shaft can be varied even when the pump is still running, while a positive displacement makes the fluid move by trapping fixed amounts of fluid and forcing it out the trapped volume into the discharge pipe. Some things that make your pumps fail is cavitation, contamination, excessive heat, overpressurization, important and improper fluid You can know some of these fails have gone wrong if your pump is making abnormal noise, high fluid temp, or slow operation. Slow operation would be like all your cylinders would be going slower than normal. The only disadvantages of a piston pump is they cost more per pump to run. The parts are prone to wear, so maintenance costs can be high. Piston pumps are heavy and due to their size, while some of the advantages are the ability to adjust, the high power density, and the able to make lots of power with mechanical energy.